Okay, so I'm gonna do a quick little video on properties of logarithms. This is really an introduction type of thing, but we're gonna do some properties. I'm not gonna do all the properties that we're gonna do in this objective on here, but it'll give us a start. So, all right, remembering that logs are exponents. If you remember that a squared times a to the fifth, when the bases are the same, I add the exponents. Okay, so it's a to the seventh. Now with logs, one thing we have not done are properties. We've done lots of solving with them, but we haven't done properties. And when what we're going to do is realize that we can expand this because this is really 2 times x times y, and I can write it into 3 separate terms. And since it's multiplication, you're going to add it. So just like when it was here, when we were multiplying, we added these. So this would be log base 4 of 2 plus log base 4 of x plus log base 4 of y. And so that is now an expanded form. Okay? So we're going to do the same thing here. And you see there are 3 different items in there, so we're going to have 3 different terms. So this is going to be the natural log, or the ln of 4, plus the ln of x squared. We're not going to deal with that exponent, how that works, at least not as of yet, plus the ln of y. Okay, 3 terms. There are 3 items in there, 3 terms. Okay, so this one we expanded, these we're going to condense. So what this means, since it's addition, I'm going to take all of these arguments and multiply them together. Because here we change multiplication to addition, so go back the other way, we change the addition to multiplication. So this is going to be log, with common log or base 10. If I multiply these together, 2 times 4 is 8, times 3 is 24, times x is 24x. Okay? All right, so these are all natural logs, so my final answer is going to have a natural log of it in it. Let's figure out what's going to go in there. Well, I have a 6 times a 2 is 12. And I have x times x times x is x cubed. Okay, maybe easier to put a parenthesis around it. Okay, so here we expanded it, here we condensed it. And that was when it was addition, and that's when it was also multiplication in it. So when we get down here, this is when we have division. And if you remember when we did division, we always asked, well, were there more of them? There were more of them on top. How many more? But really, you were dividing. Or you're dividing, but when you divide, what do you do with the exponents? You subtract them. Okay? So we're going to remember that. So here, these were really all in the numerator. Here, these are in the numerator, so they're going to stay positive, but anything in the denominator will be negative. Okay? So I have 4 terms. Yes, I realize I'm going to change this to 5x. Sorry about that. So I have 5 terms. Anything in the top is going to be in the numerator, so this is going to be log base 3 of 5 plus log base 3 of x. So I took care of all the numerators. All the ones in the denominator are going to be negative. So it's going to be minus log base 3 of 8 minus log base 3 of y. Okay? So same thing here. I have 3 different terms. This one's going to be positive. These 2 are going to be negative. So what's this going to be is the natural log, or the ln of 3, so those are all the ones on the top, stay positive, minus the ln of x squared minus the natural log of y. Okay? You could also write this as natural log of x squared plus the natural log of y and put a negative on the outside. Okay? All right, so there we expanded. Now we're going to condense. All right, since these are all natural logs, I know it's going to be a natural log, and I'm going to take everything that's positive and put it on the top. So these 2 are both positive, and again, I'm going to multiply them, so it's xy. Anything that's negative is going to go on the bottom, and I'm going to multiply it. So I have a 6 times 5 is 30, times that is z, so I have 30z that goes on the bottom. Okay, so that's condensing. So we're going to condense this one also. These 2 are positive, so they're going to go on the top. So this is log base 10, or the common log, and that's 15. All the others are on the bottom. There's an x times an x is x squared times that is z, so I have x squared z on the bottom. Okay? So we condensed and expanded. whenever you see subtraction, it goes in the denominator. Whenever it's addition, they all go in the numerator, or all the positives here go in the numerator. Okay, so we have one more thing I want to do, and this is using the properties. And we're going to break some of these down into primes, but I gave you three values. I said log base A is 1.4, log base A of 2 is 1.4, log base A of 5 is 2.7, log base A of 8 is 5.2. So these are just made up numbers, so we're going to go find some things. So I'm going to break these down. I want to break these down in, can I break down 10 into a product of any of these 8, 5, or 2? Well, log base, this is really 2 times 5, correct? Okay, so I'm going to rewrite this as log base A of 2 plus log base A of 5, and now I can substitute in those numbers. Okay, so what is that? That's 1.4 plus 2.7, and if I add those together, I'm going to get 4.1. So my answer to that one is 4.1. Okay? So 80, I got to figure out how I'm going to do this. Well, I know 2 times 5 is 10. Oh, times 8 is 80. So this is really 2 times 5 times 8. So multiplication with logs is the same as addition. So this is log base A of 2 plus log base A of 5 plus log base A of 8. I'm going to substitute in those values now. And that was 1.4 plus 2.7 plus 5.2. Well, I know that these were 4.1 already. So if I add 4.1 to 5.2, I'm going to get 9.3. Okay? All right, so the next one, I got to see, can I break 25 into a product of any of these numbers? Well, 2, no, not there. Oh, wait a minute, what about 5 times itself? Okay, so what's that going to be is log base A of 5 plus log base A of 5, which is 2.7 plus 2.7, which gives me 5.4. Okay? So we're just coming up with values using our properties. So this one's going to be division. Okay? So that's going to be log base A. This one's a little bit easier because it's already broken up for you. Of 2 minus, because it's division, log base A of 5. Well, what is that? It's 1.4 minus 2.7, and that is negative 1.3. Okay? Our second to last one is log base A of 8/5. So I have both of those values, so that's going to be 8 minus log base A of 5. And what I get, it's 5.2 minus 2.7. If I find the difference of those, it's going to be 2.5. Okay? Our last one, it says log base A of 1/4. Well, how can I get that? I know it's going to be division. 2 over 5 doesn't reduce. 2 over 8. Oh, 2 over 8 is the same as 1 over 4. So I'm going to rewrite this as log base A of 2 minus log base A of 8. Okay. Now I'm going to substitute those in there, and I get 1.4 minus 5.2, and I believe that is 2.8. Okay? So just a couple examples of giving you numbers. You break them down into smaller versions, and then use your properties, and then substitute in the numbers. Okay? Hope this helps, and I will see you next class.